What if Earth had a second Earth beneath the waves? At first, the oceans would not vanish. They would fall away from maps, politics, and memory. Then, ships would hit cliffs where no cliffs should exist. For a few minutes, nobody would understand what was changing. Satellites would still show blue water, yet the surface would keep dropping, exposing edges, ridges, and a world no one planned to see. This is the kind of discovery that rewrites everything, not because it is magical, because it is almost plausible. Imagine the first sign came from an old chart, a contour hidden in archives, a shape that appeared in paperwork for centuries, then disappeared from modern maps. The coastline stayed in mogs, not in geography. That is where the mystery begins. A place can survive longer in documents than in reality. Surveyors draw it, sailors mention it, administrators tax it. Then the sea changes and the land slips under the surface. Earth is mostly ocean, so a lost landform could vanish quietly. If it was a true island, its story would be simple. Waves erode it, storms cut it down, sea level rises and erases the last rocks. But what if it was larger? What if that island was actually the tip of a hidden shelf, a submerged plateau, or a volcanic ridge? Then the contour in the archives would not be a mistake. It would be a clue. The first hours would be the strangest part. Boats would slow down over water that suddenly looks wrong. The color changes first, then the sonar pings back with shapes. Not deep trenches, not open ocean, a broad rise beneath the surface. Within hours, crews would realize they are floating above an entire landscape. And that is where the second Earth idea becomes dangerous. Because second Earth does not mean another planet. It means another version of our own world, hidden under pressure and salt. The exposed shape would matter immediately. If the contours match old archives, then the records were not fantasy. They were describing a shoreline that once existed or still exists in a different form. Archaeologists would want the coast, geologists would want the rock, oceanographers would want the water movement. Everyone would want the same answer. Why did the outline remain in documents after it vanished from maps? One possibility is simple. The maps were slow to update. Surveyors copied older mistakes for decades, but there is a better explanation. Some coastlines are not fixed, they migrate. Deltas build outward, barrier islands break and rebuild. Coral islands sink and rise with storms, sediment, and tectonics. A shape can be real and temporary at the same time. Sea level has changed many times over human history, so the contour in the archives could mark a place that was once dry, then flooded, then partly reassembled by sand and coral. A landmass can become an archipelago can become a shoal can become a memory. Now, add one more twist. Suppose the hidden ridge is broad enough to support cold currents, trapped minerals, and pockets of unusual life. The moment it appears, the sea around it becomes a laboratory, and people on shore would notice before the scientists do. Harbors silt up, tides feel different, old fishing grounds go quiet, new shallows appear where deep water used to be. By the first day, the argument would stop being about maps. It would become about ownership. A visible landform invites borders. A submerged one creates confusion. Is it territory? Is it hazard? Is it a shipping issue? Is it a protected site? The answer depends on whether the land is actually rising or whether the sea has just moved enough to reveal it. That distinction matters. If the ridge is volcanic, it may still be alive below the crust. Heat could be building underneath. Fresh rock could crack the seabed. New vents could alter the water chemistry in a matter of days. If it is an old continental fragment, then the shape is older than the nations around it. That is a different kind of shock. Some ocean basins hide mountains taller than famous peaks, measured from base to summit. In that case, the second Earth is not a duplicate world, it is a buried one. And in the archives, the contour would suddenly make sense. Old maps often preserve the outline of what people could not fully explain. They freeze a coast at one moment in time. Later, the sea moves, but the paper keeps the old shape alive. That is why the contour survives. Paper is stubborn. It remembers even when water does not. The deeper question is not where the island went. It is why we kept drawing it after it changed. A vanished island could survive in archives because no one had strong enough reason to remove it, or because the land kept reappearing in fragments. A storm strips one side, sediment rebuilds another, coral rings the edges, then another storm breaks it again. To a mapmaker in one century, it exists. To a satellite in another, it is barely there. Now imagine the first week. Survey teams arrive with sonar, drones, and cores pulled from the seabed. They find layers. Some are marine, some are terrestrial. That combination would be the real revelation. It would mean the area was not always underwater. That single fact changes the story from Lost Island to Transforming Landscape. Then comes the surprise. The contour in the documents may match not one island, but several versions of the same place across time. A shoreline from one century, a reef pattern from another, a floodplain from before that. The archive would not be wrong. It would be layered. A coastline can shift many meters in a single storm season, so the old documents might be doing something modern maps usually do not. They could be preserving a chain of transitions, not a fixed border. That makes the hidden land more interesting than a vanished island. It becomes a record of motion. A second Earth under the waves would not be a twin planet. It would be a compressed version of Earth itself. Mountains, coastlines, and habitats all stacked under pressure. Think about the scale. From space, we see smooth blue water. Below it, the bottom has canyons, plateaus, volcanic cones, and fossil shorelines. If the sea suddenly thinned, the planet would not look empty. It would look crowded. The illusion of simplicity would collapse. Then the maps would spread. Shipping companies would redraw routes. Insurance models would change overnight. Coastal cities would worry about the same thing in reverse. If the seabed is rising there, what happens here? Because a revealed ridge can redirect waves. It can alter tides. It can protect one shore and punish another. A hidden island is not just a curiosity. It is a machine inside the ocean. It changes currents. It bends weather at the local scale. It creates calm on one side and turbulence on the other. That means the discovery would matter far beyond the site itself. And the archives would suddenly become political evidence. Old claims, abandoned names, forgotten ports, vanished anchorages. Every line on the page becomes a potential argument. But the strangest part comes when scientists compare ages. If the rock is young, the island may still be growing. If the rock is old, the island was once much larger. If the sediments are mixed, then the land was repeatedly exposed and drowned. Each result tells a different story. None of them are ordinary. A young volcanic rise suggests a living process under the sea. An old continental fragment suggests a long-lost edge of a continent. A mixed record suggests cycles so persistent that humans only caught the last few frames. The last 12 years reshaped coastlines faster than many civilizations could record. That is why the contour remains in documents. Humans write during one phase of a landscape and then forget the next phase exists. The archive becomes a fossil, not of the island itself, but of our relationship with change. Now picture the public reaction. News helicopters circle above a wide, pale shape in the water. Dry sandbars appear where fishermen used to drop nets. Tide tables fail. The shoreline redraws itself in front of cameras. But the real story is below the surface. The exposed rim is only the beginning. Under it, sensors detect an even larger rise. Beneath that rise, there may be cavities, volcanic heat, or old sediment packed with the record of vanished climates. A second Earth would not be made of cities and forests. It would be made of time. And then the final twist arrives. The contour in the archives might not point to one island